I'm from Faculty of Mechanical Engineering, University of Belgrade. But before I start with this presentation, I must say that this research was predominantly done by my colleague Nikolina from University of Split, Croatia, but unfortunately she couldn't come, so she asked me to present the paper. So this topic is about the use of wearable sensory devices for metabolic rate estimation in office buildings. So when we are discussing about thermal comfort, we must start with Funger's definition of thermal comfort as its state of mind of occupant satisfaction with the surrounding thermal conditions. But usually we always have some number of occupants which are dissatisfied with even the best possible conditions in buildings. Why that occur? Because physical conditions of environment are very easily to measure, but besides them, also personal factors are very important. Personal factors such as health of every individual, then his age, his also behavior, his habits, cultural habits and his own habits, also the age, and all that personal factors affects also the thermal estimation of every environment. So besides that, the thermal comfort affects occupant health, productivity and behavior. Also, the behavior of occupants further affects the energy usage in buildings if the occupants have the opportunity to set the system as they want. If we have to calculate into the thermal conditions for every environment, it's very easy if we measure the physical parameters of the environment. But there are such personal factors which are very difficult to be measured, like a metabolic rate of each individual indoors. So it's usually done like we just have to take the standard and to adopt one metabolic value for activity, for example, in one office, and then to calculate, for example, PMV for that environment. But in real conditions, metabolic rate is a dynamic factor which changes through the day, which is different for each person. So this presentation tries to find the solution for that problem. This research was performed using sensing devices, which are the best available at the market at the moment. So they were a useful tool to track user activities during the working day. As I said, user activities were dynamic. So we have in office environment different activities. Okay, sitting, for example, in peace, then working some light tasks, but also we have some walking or some even more energetic activities during the day. So all these activities impacts the metabolic rate of each person. So these sensing devices provides a secure information and gives the possibility to calculate more precisely the thermal comfort parameters inside each building. Besides these parameters, also gender differences are found by different authors as an influential factor for their estimation of indoor environments. Some of the studies which were performed in laboratory conditions stated that there is no significant difference between genders. But on the other hand, the studies which were done in field showed that there are significant differences among the genders. So they stated that women are more sensitive to temperatures while men prefer colder environment conditions, especially in office buildings. So, having in mind all these things that we were discussing, the aim of this study was to explore the linkage between the user age, gender, and also season of the year, and to link it with metabolic dynamic rate of each occupant. So the study was done in 2 buildings in Croatia. First of them was University building in Split, and the other one was public company building in Zagreb, also in Croatia. 8 persons participate in this search. Maybe someone would say that 8 persons is not enough as a huge sample for the conclusions, but if I may say, it's just a start and a good idea for a future research. So in building A and B, we had 4 participants. 3 of them were men and 5 women. They were divided in 3 groups by the age. So first group from 35 to 44 years, then second group for 45 to 54, and the last group was 55 to 64 years old. Monitoring was performed for 7 days, 4 times during the year, also in heating, but also in a cooling period. So measurements were performed as it is shown in the periods, as it is shown in table 3 for each building, but there were a few days in between the measurements in 2 buildings during the usage of the same equipment. Unfortunately, there were no enough equipment to have the measurements during the same days in each city. Besides the measurement, there were also survey protocols, so users had to report their thermal sensations 3 times during the day. And after all data were gathered, statistical analysis was performed using statistical software to determine the significance of all tested variables, which were age, gender, and season of the year, and its impact on a dynamic metabolic rate. So users were asked to wear the sensing device called MOVE 3, which is triaxial accelerometer for activity recognition. So they had to wear it clipped on their hips for 8 hours during working day. So sensor recorded the raw data on 3-day acceleration, barometric air pressure, and temperature. All data were gathered in an interval of 1 minute. After the data was gathered, the metabolic rate of each occupant was calculated using MovieSense data analyzer software. In order to get the idea of statistical significance of the results, 2 tests were used. First, parametric t-test was used to determine the statistical significance of difference between metabolic rate of men and women and the difference in metabolic rate during heating and cooling season. And another test, Kruskal-Wallis test, was used to identify significance of metabolic rates difference among the occupants which were different age. So first test results showed that there were no statistical significance between the man metabolic rate and between the woman metabolic rate during the office work. And the second test, Kruskal-Wallis test, showed that there was a significant difference statistical between the building occupants of different age in their metabolic rate. So occupants were divided in 3 groups, as I said, and also according to the test of influence of metabolic rate during the season, there were registered changes during the 4 different seasons during the year. So 4 of the 8 occupants have different metabolic rates in the season, and 4 of them had a very similar one. So these results really should be tested in a large sample of participants, but of course it's very difficult to perform in real conditions because you have to disturb the occupants during their working day. Also, measurements of dynamic metabolic rate were performed for 8 hours during working day, and together with occupant satisfaction through questionnaires, this table was formed, dividing in 3 groups by the age of the participants, then their answers about acceptability of thermal environment, and also by the value of the metabolic activity. So 3 groups were recognized. First one, the youngest one, which stated that higher temperature are in acceptable range during this study. Most number of occupants were females in this group. Second group was mostly male group, so also younger one, and they had higher activity level than first group. But even though they had the higher activity level, that activities did not provoke them to have warm sensation. Third group, which was the eldest one, with people with a high body mass index, they stated that their comfort range is very narrow. They also had the lowest metabolic rate, of course. And here in these tables, it can be seen that the results of metabolic rate are very different than the rates prescribed by ASHE standard for office activities. So the rates here varies in the range from 1 to 2.3 MET, while in ASHE standards there are much narrow values for typical office activity. So according to all these results, it can be concluded that dynamic metabolic approach is very important in taking into consideration during the thermal performance assessment for each building. So the results showed that there is no significant difference between the mean metabolic rate in working day between males and females. But on the other hand, there were a statistical difference between building occupants of different age. Of course, further research is necessary. The number of examples must be wider. And also the future research will concentrate on developing personal comfort models to predict individuals' thermal preferences. Model will be validated, and after that algorithms will be provided for personal occupants profiles in order to find the best situations which occurs in real buildings, in which are totally different conditions than in controlled laboratories one. Thank you very much.